Hi students, next topic of matrices is rank of a matrix. Rank of a matrix is very important property of a matrix. It is useful for solving equations, for finding linear independence or dependence of vectors. So there are many uses. So first of all, let us know what is rank of a matrix. So now, before understanding the rank, first of all we need what a submatrix is. Like a subset to a set, similarly submatrix is a small part of a given matrix. Here you can see in this slide, okay, here is one matrix. This is a matrix which is given. So the different parts of it obtained by deleting any number of rows or any number of columns from it, we get a smaller matrix, that is known as submatrix. So matrix itself is a submatrix of it itself. So this is the first case that we have taken the same number of rows and columns, so it is called submatrix. As a set is subset of itself, similarly the full matrix is submatrix of itself. Now in the second, you can see we have deleted one column. So from the given matrix, after deleting one column, we obtain this. Similarly here, obtaining deleting one row, keeping all the column, and you can delete one column, two rows, or two column, one row, two column, two rows, or you can delete all the three rows and three columns and you get a one by one order matrix in this way. So there are many ways in which you can obtain a submatrix from a matrix by obtaining any row or any column from a matrix. Now after submatrix, the next concept that must be understood before defining rank is minor. So what is a minor? Minor is the determinant of a square submatrix of order R. If we say minor of order R, that means you have different submatrix obtained from a given matrix. So when you find the determinant of a square submatrix, that is called minor. If like in this first case, you have minor of order 3, that means you have 3 rows and 3 columns and you obtain the determinant of that matrix, and it will be called minor of order 3. If you have a submatrix of order 2 by 2, that means 2 rows and 2 column, and its determinant will be called minor of order 2. Similarly, if you have only 1 row 1 column, then the minor will be of order 1. So we have many submatrix from a matrix. Submatrix can be rectangular, can be square, but minor is possible only for a square submatrix. So out of the different submatrix which are square, we have to write its determinant, and that will be called the minor, right? After these two concepts, now we will be able to define rank. So what is rank? Rank is just a number. What is that number? That is the order of the minor which is not 0, which does not vanish. Let if the minor of order R does not vanish, plus all the minor of order R plus 1, all the minor of higher order, all vanishes, then the rank of A is called R, right? So this is the definition. That means for a given matrix, you have to find the determinant, right? Starting from the highest, let the matrix be of order 3 cross 3, you will find the determinant of this, and that will be known as minor of order 3. If that is not 0, then the rank is the order of that minor, that is 3. The rank will be 3. If this is 0, if you obtain the determinant of 3 by 3 order minor and that is 0, then you will consider the lower order. You have to come down for finding the minor if the higher order becomes 0. So this is the condition that rank of a matrix is R. If R is such a number, that means it is the order of the minor which does not vanish, and all the higher order minor vanishes. So that means rank is denoted by this symbol. This is the symbol of rank, row. It is known as row. So this is rank of A. It is written in this way. So this is the concept of rank. Now the from this the extract is, after going through these slides, we have come to know that rank is the largest order. Now this is the simple definition. This is the largest order of a non-vanishing minor. Right? From a matrix, you will be given a matrix of any order, out of which what you have to see, you have to see a minor which is of largest order and non-zero. So that order will be the rank of a matrix. Right? If a matrix is non-singular matrix means if the determinant of a matrix is non-zero, then it is called non-singular. If its determinant is not zero, that means its highest minor will be its order. So if it is of order n, then n will be the rank. Right? Now this concept will be more clear to you when we consider some examples. So let us see this example, rank of A. So here we are given some matrix. In question paper you will be given a matrix and you will be asked to find the rank. Like here one matrix is given and you have to find the rank of this matrix. So what you will go through to find the rank, you have to first look at this matrix and see what is the highest order minor exist in this. So highest order minor is of 3 by 3 order. So largest minor is this one itself, because it is of 3 by 3 order. So it is the highest minor. So we find the value of this. So determinant of A we find, and this is the process. You know that we have expanded with the first row using the determinant that we have studied in lower classes. The first row expansion has been used here. So the determinant comes out to be minus 176, which is not 0. The highest order minor, which is non-zero, is of order 3. So that means rank will be 3. So rank is nothing but the order of the highest minor which is non-zero. So it is non-zero, so that will be the order of the minor and also the rank. Now if this highest order minor that exists in a matrix is 0, then what to do? So let us see in the next slide. So here again we have to find the rank of a matrix. This is another case in which the again you have 3 by 3 order matrix. That means highest minor that can exist will be of 3 by 3 order. So highest minor will be of order 3. So we will check the minor of order 3, that is matrix itself. The determinant of that matrix is 0. So we find again by expanding with respect to first row, we get to know that the determinant is 0. So if it becomes 0, it means rank cannot be 3, because minor of order 3 is 0. So we need rank which order minor is non-zero, minor is non-vanishing. So rank cannot be 3. So rank cannot be 3. That means we have to check for rank can be 2 or 1. So we have to start from the highest order, and then we have to come down for 2, 1, 0, etc. So now we will check for order 2. So out of this matrix, you have to find a minor of order 2. So order 2 minor can be many, like here the example I have taken. So this is, you can consider this one. So this is a submatrix, square submatrix. Its determinant will be minor of order 2. So this has been written here, and after evaluating it, it is again 0. But this is not the only minor that we have. We can check this one. So this is also minor. Minor means a submatrix, and submatrix means the matrix obtained by deleting some rows and column from a given matrix. So in this way you have seen again it comes out to be 0. So here again we have all the possibilities, like in the we can take the case of the first one, first two rows and columns. So that it is written here 2 3 3 6 here. So if we evaluate this minor obtained from here, then what is the answer? Answer is 3, which is non-zero. So at least one minor of order 2 is non-zero, means the rank will be 2. So we have to look for a minor which is non-zero. So if we have 2 3 4 minors of order 2 becoming 0, but at least one is non-zero, so this is the condition, at least one minor of order 2 if we find which does not vanish, which is non-zero, then the rank will be 2. The non-vanishing minor we need, and its order will be the rank. So this is the second case where we find the rank of a matrix using this method, and this method is known as that because there is not only one method to find the rank of a matrix, there are many methods. So this is the first one, which is known as determinant method. Now this is another possible case in which you are given this matrix which is not square. As in the last two examples we have seen that both the matrices were square matrices. So this is not a square matrix. Then what is the process? How we look for the minor of higher order? So what is the highest order minor that can exist in this? So because it is not a square matrix, so out of this, what is the highest order submatrix that it can have? So because it has only 2 rows, so 2 by 2 will be a highest order submatrix. So the minor of this, we have to start from the highest. So highest or largest minor will be of order 2, and its value will be, like in this case we have evaluated the value of the minor by cross multiplying, and which is -1, which is non-zero. That means minor which does not vanish, its order will be the rank. So the order was order of this minor was 2, so therefore rank is, it is not exactly written here, there is mistake in this, so this is not correct. Rank of A is 2, right? Because minor of order 2 does not vanish, and order of the minor is the rank. Order of which minor? Which does not vanish, right? So this was again a question. So now these were the question of finding rank. Now we look for more complex questions like this one. Find the value of a matrix such that rank of this matrix is 3. Up to now we are finding the rank, but in this question rank is already given to you. Rank is given to be 3, and what you have to do, you have to find the value of x. So we have to find the value of x such that rank is 2. So you can see this matrix is of order 3, and rank is also given to be 3. When the rank is 3, when the minor of order 3 is non-zero, then only rank can be 3, right? So this is the given matrix, its rank is 3. That means its determinant must not be 0, because if the determinant is 0, determinant means minor of order 3 is 0, then rank cannot be 3. Rank is 3 means minor of order 3 is non-zero. So determinant we find and we put it not equal to 0. Now in this question, like in previous question, we have used the idea of finding the determinant by expanding with respect to row or column, but here we have not used that concept, because it contain the, you can see this matrix, it has x, y, x, a, b, c, like these are the elements. So multiplying these, expanding this will be very clumsy process. So to avoid this, what we are using here, we are using properties of determinant that we have done in the lower class. So what is done here, we have added column 1, column 2 and column 3 in place of column 1. So column 1 plus column 2 plus column 3 we have done. So what does that give? That give that the first column has same entries, so you can take that common. So again in the next step we take x plus a plus b plus c common, and we are left with 1 1 1 in the first column. After you get 1 1 1 in the first column, you have to keep the first row as it is and subtract the second and third row from first to get 2 zeros there, so that the expansion of the determinant become very easy. So in the next slide you can see here that this was the matrix obtained by taking common this element. Now by using the subtracting the, this has column 3 minus column 1 and column 2 minus column 1. After this operation you get these two elements to be 0, and when these two elements become 0, then you get this type of matrix, which means this is a triangular matrix, and determinant of a triangular matrix is product of its diagonal element. So just we have multiplied the diagonal element, which is 1xx, that means x square. So this is the determinant, and on the other side we have written not equal to 0, not equal to 0, not equal to 0. Why? Because the rank is 3, that means determinant must not be 0. So not equal to 0, if the product not is equal to 0, that means the first and the second both terms should not be 0. So that will give us x not equal to minus a plus b plus c, and x not is equal to 0. So that is the value of x that we obtained for the condition that the rank is 3, right? So this type of question you can do. So